All right. So today we're going to use visual models to add two fractions with related units using denominators 2, 3, 4, 5, 6, 8, 10, and 12. But first I want to ask, can I do what's on the screen right now? One banana plus one orange. What would you get? Two oranges, two bananas, two um what would you get? You would you would get like a you'd have a banana um and an orange, and it would be all yellow and all orange, and I guess what I'm trying to say is that it just wouldn't make any sense. But if we look at it from another perspective, what do bananas and oranges have in common? They are both pieces of fruit, so instead of labeling banana and orange, we find what they have in common and say that one banana plus one orange equals two pieces of fruit. Which makes a whole lot more sense. Well, we can carry that same knowledge over when we talk fractions and adding them if they don't have like denominators. Take 1/3 plus 1/6, for example. So right here we're going to show 1/3, and right here we're going to show 1/6. If I wanted to add 1/3 plus 1/6, I would find that the denominators are different. They're not like denominators. So right here I have one banana plus one orange. That's a problem. So I need to find their similarities. So right now we're going to go with shade in 1/3 and then shade in 1/6. So we've done our job. The units are different, but they need to be the same. So in your head, what is a multiple of 3 that is also a multiple of 6? Running through the multiples of 3 in your head. 3, 6, 9, 12, 15. So we know that 3 times something will get to 6. 3 times 2. So we need to partition each third in half, or into 2 pieces. So now I have 1, 2, 3, 4, 5, 6. I have 6 pieces. Now, if we look at, we don't have 1/3 anymore, we have 6 total pieces, and 2 shaded pieces. So looking at 1/3, 1/3 really doesn't exist anymore. It is actually 2/6, because 1/3 is equivalent to 2/6. Now we find that they have like denominators. So 6, 6, and our denominator of 6. And we look at the numerators. 2 plus 1 equals 3. Looking down here, we made them all 6, so we can just count the shaded regions. 1, 2, 3. 3, 6. For the next one, we do the same kind of idea. We have 1/2 and 1/8. So right on this top one, we're going to show 1/2. On the bottom, we're going to show 1/8. Go ahead and shade in 1/2 and shade in 1/8. Now they look wildly different because we are essentially comparing a banana to an orange. And we're trying to mash them together and make some crazy hybrid, but we need to find what they have in common. In our head, listing out the multiples of 2. Let's run through them. 2, 4, 6, 8, 10, 12. Can we find a multiple that 2 and 8 have in common? Yes. 2 times something equals 8. 2 times something equals 8. 2 times 4. So we need to partition our half, each half, into 4 pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 is truly 1, 2, 3, 4 out of our 8 total pieces. Now, they are both 8ths, so they both have that in common. Really, it's not 1/2 anymore. 1/2 is equivalent to 4/8. So we can count our shaded regions, 1, 2, 3, 4 on this top one, and 1 on the bottom. 4 plus 1 equals, count your shaded regions, 1, 2, 3, 4, 5. 5 of the 8 total pieces. Not so bad so far. Now we can also show this on a number line. Let's see, go with 1/6 plus 3/12. Now what do you notice about these two fractions? Hopefully you notice that they do not have like denominators. And that 6 and 12 would have something in common. But first, let's show on a number line. Draw out your number line. From 0 to 1. And first, we are going to partition it into 6. So we're going to find out where 1/6 is right away. 6 is an even number. I can partition it in half. What times 2 equals 6? 3. So I can partition these halves into thirds. Here I have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, or 1 whole. I want to place 1/6, and now I need to add 3/12. Well, that's a problem, because 6 and 12, although they will have something in common, they do not have like denominators. So you can't hardly add them up. It's like adding a banana plus an orange. You get a borange. Doesn't exist. Not yet anyway. So how are we going to change this 6 into 12? Well, if you think about your multiples of 6, 6 times what equals 12? 6 times 2. So we can take each one of these 6ths and we can partition each 6th into 2 pieces, or each 6th in half. Excellent. So now, instead of 1 6, 2 6, 3 6. We can label out. We have 0 twelfths, 1 twelfth, 2 twelfths, 3 twelfths, 4 twelfths, 5 twelfths, 6 twelfths, which also happens to be 1/2, 7 twelfths, 8 twelfths, 9 twelfths, 10 twelfths, 11 twelfths, and 12 twelfths, or 1 whole. So, in comparison to our benchmark fraction, we notice that 1/6 is less than 1/2, and 3 twelfths, we'll put that down there, is less than 1/2, because our 6 twelfths is equivalent to 1/2. So now let's show if we did 1/6, so we made this jump right here from 0 plus 1/6, that landed us right there, which happens to be 2 twelfths. Now we need to take 3 twelfths. 1, 2, 3. And we landed on 5 twelfths. So 1/6 plus 3 twelfths equals 5 twelfths. Now we know that because we had to find a common denominator. So really, what we actually did was not 1/6, we did 2 twelfths, because those two are equivalent, plus 3 twelfths, and that equaled 5 twelfths. All right. Rock on. Remember that you can't add a banana plus an orange. You'd get something that doesn't exist. But you should see them as two pieces of fruit. So when you look at two fractions that do not have like denominators, you shouldn't look at them as trying to make a mutant. You just need to find out what they have in common. So in this one, 3 and 6, you could have a common denominator because 3 times something would equal 6. Using a number line, partitioning into that larger unit first, so the one that has the bigger pieces. 1/6. 6 being a smaller number, it has larger pieces. Then once you mark that, you can find out what 6 and 12 have in common. Well, 6 times 2 equals 12, so you can partition that each sixth into two pieces and add your twelfths.